Hello, Algebra 2. We're going to take a look at 8.7a samples in preparation for 8.7a quiz, where we are practicing with solving linear systems in preparation for solving quadratic systems. So we're going to practice the two different methods that we reviewed for solving linear systems. The first method that we reviewed was solving using substitution, and that's going to be our method for sample 1 here. Solve this linear system using substitution. What that means is we want to find the 1x and the 1y value that will solve both of these equations and make both of them true. We notice the second equation is solved for y, so this is a system that is solved most easily by substitution. So we're going to take the second equation that is y equals 2x plus 3. We're going to take that 2x plus 3 that we know is the same thing as y, and we're going to put it in place of the y in the first equation. So this arrow tells me I am rewriting my first given equation as 15x minus 5 times, instead of this y, 2x plus 3. I'm replacing this y with 2x plus 3 because the second given equation is y equals 2x plus 3. And then we're still equal to 30. All right, so now that I've rewritten this very first given equation so that the y is replaced with 2x plus 3, now I only have one variable, and I can solve this equation in one variable. I'm going to leave this y equals 2x plus 3 equation alone. Remember, these are our given equations to start with. And right now I'm just going to work with rewriting that first equation so that it only has x variables. Solve it for x will be my next step. So I'm going to use the distributive property. Negative 5 times 2x is negative 10x. Negative 5 times 3 is negative 15. Everything else stays the same. My next step, moving from here down to this step, is going to be to combine my like terms. 15x minus 10x is 5x. Everything else gets copied. Then add 15 to both sides, giving us 5x equals 45. Divide both sides by 5, and I know the value of x is 9. Now I'm going to use that information. I know that in both of my equations, x can be 9, but I need to figure out the corresponding y value that will also work for both equations. So I choose either one of my first two given equations. This is my system here, these two equations. And I'm noticing my second equation might be the easiest equation to use to find out my y value. I could use the first equation or the second equation. I can use either given equation. This one looks easier. So here's my arrow telling me I'm going to rewrite it, and in place of x, I'm going to put 9, because that's what I figured out x is. And when I do that, all I have to do to figure out the value of y is 2 times 9, 18, plus 3 is 21. X is 9, y is 21. We are going to write that solution as an ordered pair because remember, the visual concept behind what we're doing is if we were to graph these two linear equations into their respective lines, we're looking for the point of intersection of those two lines because the point of intersection will be the 1x and the 1y value that exists on both lines. And that will be the 1x and 1y that will solve both of these equations and make them both true. So our ordered pair will be the way we will box up our solution. Second and last sample for today is solving another linear system. Here is your linear system right here, these two equations. This is your given, these two equations. And we're going to use elimination because in this case, elimination will be the easiest method to solve this system. Notice that neither one of these two given equations is solved for either y or x. We don't have y equals something or x equals something. So substitution won't be the easiest method here. Elimination will be the easiest method, and we have the x's and the y's lining up. All we have to do is rewrite one or both of these equations in higher terms so that we create opposites. So we ask ourselves to create those opposites, what do 2 and 7 both go into? They both go into 14, so we're looking for the least common multiple of 2 and 7. I could create opposites 14x and negative 14x, or I can look at the coefficients on my y terms and ask what do 4 and 3 both go into? What's the least common multiple of 4 and 3, and that's 12. So I could create 12y and negative 12y, and in fact that's the choice I'm going to make. Usually I go with whatever is the smaller least common multiple. 2 and 7 go into 14, 4 and 3 go into 12, so I'm going to choose 12 because it's simply the smaller number. What do I need to multiply by to get one of these to be 12y and the other to be negative 12y? Well, one of them is going to have to be multiplied by a positive number, the other by a negative number to get the opposite signs. Now remember, I'm trying to get the 12y, so 4 times 3 is going to give me my 12, and 3 times negative 4 is going to give me my negative 12y here. But I can't just multiply the y terms by those numbers. I have to multiply the entire equation by those numbers to keep it true. So 2x times 3, 6x. 4y times 3, 12y. 40 times 3, 120. Second equation, negative 7x times negative 4 is positive 28x. 3 times negative 4 is negative 12y. Negative 4 times negative 4 is positive 16. Now it's time to add these two equations. So once I have created my opposites, I want to add the two equations together in order to eliminate one of the variables. So when I add 6x plus 28x, I get 34x. The 12y's cancel out and are gone. 120 plus 16 is 136. Then to get down to x, I divide both sides by 34, and here I am working out that long division. So it turns out x is 4. Now I'm going to use that 4 that I found out is the value for x to figure out the y value that's going to work in both of these equations. So I pick either equation. It doesn't matter which one of these two original given equations. I chose the first one. You could have just as easily have chosen the second. Whichever one looks easiest for you is the one you want to pick. So I'm going to put 4 in place of the x. Everything else in this first equation will get copied. And then I simplify. 2 times 4 is 8, plus 4y is 40. Subtract 8 on both sides, and we have 4y is 32. Divide both sides by 4, and we find the value of y is 8. And again, we're looking for the point of intersection. If we were to graph these two lines, that point of intersection would happen at 4, 8. X is 4, y is 8 is the one x and y value that both lines share. It's the one x and y value that will solve both of these equations. Okay, once you have these samples included on your lesson paperwork, it's time to move on to today's quiz. And we'll see you next time.